In the first part of calculus, we discussed extensively the properties and processes of differentiation and integration. In the second part, we will start by discussing the applications of integration. So to begin with, let us start by reviewing some basic differentiation and integration rules. For example, the derivative of u to the power of n with respect to x. Remember, u is a function of x, like say 2x plus 1 or sine x and so on. So the derivative of u to the power of n with respect to x is n u to the power of n minus 1 times the derivative of u with respect to x. For example, what is the derivative of sine cube x with respect to x? It will be 3 sine squared x times the derivative of sine x, which is cos x. Alright, therefore, what is integral of u to the power of n du? It will be u to the power of n plus 1 over n plus 1 plus c. Another one, the derivative of sine u with respect to x is cos u times the derivative of u with respect to x. For example, the derivative of sine of 5x is cos of 5x times the derivative of 5x with respect to x is 5. So, derivative of sine 5x is 5 cos 5x. And therefore, what is integral of cos u du? Integral of cos u du will be sine u plus c. Alright? The derivative of cos u with respect to x is negative sine u times u prime. And therefore, integral of sine u du is negative cos u plus c. Alright? The derivative of tan u with respect to x is secant squared u times the derivative of u with respect to x. And therefore, what is integral of secant squared u du? It must be tan u plus c. The derivative of a over u equal to negative a over u squared u prime. You see that? The derivative of a over x is negative a over x squared. Therefore, what is integral of negative a over u squared du? It will be a over u plus c. Or integral of a over u squared du will be negative a over u plus c. Now finally, the derivative of ln u equal to 1 over u times u prime. Therefore, if you integrate 1 over u with respect to u, integral a over u du will be a ln u plus c. Now, you must be very familiar with these integration rules in order to proceed into our second part of this course. Alright, so maybe write them down and learn. That's the best way to learn these. Alright, let's talk about definite integral. What is a definite integral? In other words, what does this represent? Integral a to b f of x dx. What is the physical meaning of that? Well, the physical meaning of this is integral a to b f of x dx is a measure of the area enclosed by the graph of f of x with the x-axis. That's right. It represents the area enclosed by the graph of f of x with the x-axis from x equal to a to x equal to b. That's why it's called a definite integral. Now, suppose we have, this is the function of x, f of x, and this is x equal to a, and this is x equal to b. Now, shade that area. This area is actually given by this definite integral. So the meaning of integral a to b f of x dx represents the area enclosed by the graph of f of x with the x-axis from x equal to a to x equal to b. And that must be very, very clear, and we will be using this as we move on. Alright, that leads us to the concept of area of a region between two curves. Now, let's talk about this. What does integral 0 to 6 x squared minus 6x dx represent? Well, as we said earlier, it will represent the area enclosed by the graph of this function. Your f of x is x squared minus 6x. If you draw the graph of this and measure the area enclosed by the graph of this with the x-axis from x equal to 0 to x equal to 6, that will be a measure of that definite integral. So what is the physical meaning of this statement? This definite integral represents the area enclosed by the graph of f of x equal to x squared minus 6x and f of x equal to 0. Remember, f of x equal to 0 is the x-axis, y equal to 0, between x equal to 0 and x equal to 6. Now, if you look at this, this is the graph of x squared minus 6x. And it cuts the x-axis at x equal to 0 and x equal to 6. And all that area is below the x-axis. Is that right? Yes. So, is this area a positive or a negative quantity? All of this area, the area enclosed by the graph of this function, with the x-axis from x equal to 0 to x equal to 6, is below the x-axis. It means that this is a negative quantity. The area enclosed by the graph of a function with the x-axis, if the area is below the x-axis, that is a negative quantity. If the area is above the x-axis, it is a positive quantity. Now, let's do this now. You know how to integrate this quantity. Integral x squared is x cubed over 3, x to the power of n plus 1 over n plus 1, x to the power of 2 plus 1 over 2 plus 1, minus 6 times what is integral of x dx. It will be x squared over 2. Now, this quantity is now measured from x equal to 0 to x equal to 6. The lower limit is 0, the upper limit is 6. Now, how do we find the value of this? First, replace x by the upper limit. So, we have x cubed is replaced by 6 cubed. So, that will be 6 cubed over 3 minus 6 times 6 squared over 2. So we have now used the upper limit. Now minus, now use the lower limit. But when you use the lower limit, x equal to 0, both these quantities become 0. So that will be 0. So you have the upper limit value minus the lower limit value. Now simplify this. You don't need my help to do that. That will be negative 36 square units is that area. That means the value of this definite integral is negative 36 square units. The area enclosed by the graph of this with the x-axis from x equal to 0 to x equal to 6 is a negative quantity. The area is below the x-axis. All right. Let's talk about this now. What definite integral represents the shaded area in here? Now here, if you notice, the shaded area is actually the area enclosed by the graphs of two functions. Now, the straight line represents the function g of x equal to 2x plus 5. And the parabola is the function f of x equal to x squared plus 2x plus 1. Now, look at the 2 points where they meet. They meet at x equal to -2 and at x equal to 2. That means this area is a measure of the area enclosed between g of x and f of x from x equal to -2 and x equal to 2. Right? So, this is the area enclosed by the graph of g of x equal to 2x plus 5 and f of x equal to x squared plus 2x plus 1. In fact, I don't even need to mention the limits because the area enclosed by these two graphs exists only between these two x values. So, the boundaries of this area are the points of intersection of the two curves. Now, how do you find the points of intersection? The point of intersection occurs where these two function values are equal. So what all we need to do is set f of x equal to g of x and solve for x. So this is our f of x and this is our g of x. Set it equal to 0. Set them equal to each other. Is that right? Where they intersect, the functions are equal to each other. Now, solve this equation. Now, follow these steps. I just moved these terms to the left. And now, combine terms. That gives you x squared minus 4 equal to 0, which is x minus 2 times x plus 2 equal to 0. Gives you x equal to 2 is one value, and x equal to -2 is the other value. That means one point where they intersect is x equal to -2, the point corresponding to x equal to -2, and the other is x equal to 2. Therefore, this is the area enclosed by the graph of g of x equal to 2x plus 5 and f of x equal to x squared plus 2x plus 1 between x equal to -2 and x equal to 2. Can you write this area as a definite integral? I'm going to leave it for you. Alright. The area enclosed by the graph of g of x equal to 2x plus 5 from x equal to 2 to x equal to, from x equal to -2 to x equal to 2. Can you write this as a definite integral? Now this is one of the functions we just talked about earlier. G of x equal to 2x plus 5. Now what is the area enclosed by this from x equal to -2 to x equal to 2? What definite integral represents that? Well, that will be integral -2 to 2 of 2x plus 5 dx. And that is a measure of this area. In other words, the area enclosed by g of x with the x-axis. That's right. And is given by integral -2 to 2, 2x plus 5 dx. That's right. This is a measure of the area enclosed by g of x equal to 2x plus 5 with the x-axis. Now, let's take the other function, f of x equal to x squared plus 2x plus 1. And look at that area. The area enclosed by f of x equal to x squared plus 2x plus 1 from x equal to -2 to x equal to 2 is this definite integral.